lesson 6.3 for pre-algebra. The title of this lesson is Similar Figures and Scale Factors, which we'll get into later. It says two figures are similar if, number one, the corresponding angles have the same measure, and number two, the lengths of corresponding sides form equal ratios. So in this lesson, they will tell you if two figures are similar figures, and then you have to take the numbers and figure them out. So if you notice here, 5 doubles to 10, and then 8, these are both 8, doubles to 16. So we know that these are similar figures. Okay, so triangle CAT and triangle DOG are similar triangles. Find the missing length, x. So what you want to do, step one, is set up a proportion, okay? So I'm going to take x, and I can take either side. I can pick 32 or I can pick 24. It does not matter. So I'm going to pick 24, and I'm going to set up a proportion, x over 24. Notice those are the two that I've circled, and those are both in CAT, okay? I am going to set them equal to DOG, and I'm going to figure out their counterpart. So if I look at x is on the top, I look at what goes with x. Well, 50 goes with x, so I'm going to put 50 on the top. And then 24 goes with 30, so I put 30 on the bottom. So you have to set it up correctly. If you don't set up your proportion correctly, you will get wrong answers. So after I do this, I set up a proportion. I do x over 24 and 50 over 30, just like this. So then I'm going to cross multiply, and I get 30x just right there, and 24 times 50 is 1200, and then I divide by 30, and I get x equals 40. So I know that this length of this triangle needs to be 40 centimeters. So they use this all the time. If you've ever seen where a company wants to build a huge building, well, they don't just go and build the huge building. A lot of times they set up a little prototype of the building. Have you ever seen those on, they're like, they carry them around, and it looks just like the regular building is going to look, but it's a tiny little thing that they can take into a meeting. So they definitely use proportions to figure out, okay, if my regular wall is 20 feet high and I want it to be 1 or 2 inches high, then I have to do this whole proportion. So they use it a ton. Okay, so these trapezoids are similar figures. Find x. Okay, so they give you a lot of stuff. There's a lot of stuff going on, and you do not need to use all of it. If you remember, all I need to have is x and another side here. So I can pick any side I want. So I'm going to pick 12. And then I have to find their corresponding sides. So x is my bottom. So I'm going to set up a proportion. Okay, so they used 10, which is the exact same thing. So they used 10 here. So then they did x over 10, so that's here. X and 10 go right there. They go together. And then x goes with this 10, so there's that 10 right there. And this 10 is on this diagonal, and that goes with this diagonal, which is 5 right here. So you set up a proportion, cross multiply, 10 times 10 is 100, 5 times x is 5x, divide, and you get x equals 20. You can set up the proportion with a bunch of different number combinations, but 20 is the only correct answer. So if I would have used the 12 that I originally circled, so I could do x over 12, just like this, and then I would set it equal to 10 over 6, because x goes with 10 and then 12 goes with 6. I cross multiply and get 6x equals 120, and then I divide by 6, and x equals 20. You will only get one correct answer, but you can use a ton of different ways. Okay, Story problems, similar figures. So, a 6-foot tall person standing near a flagpole casts a 4.5-foot shadow. The flagpole casts a 15-foot long shadow. What is the height of the flagpole? Now, you would use this because no one wants to scale up a flagpole and try and measure it with a measuring tape. So, this is called indirect measurement. It's not going to give you an exact measurement, but it'll tell me roughly how tall this flagpole is. They use this all the time if you've ever seen those logging shows where they cut down those enormous trees. Well, somebody puts in an order for a 70-foot beam they want in their house. They want this awesome 70-foot beam. Well, if a guy just goes down and cuts down a regular tree and doesn't measure it, he could get a 60-foot tree, and that's not going to work. So they have to be very precise. So what you're going to do is, I drew a little picture. So a man, a 6-foot tall person, so here's my person, 6 feet tall. So that's 6 feet. Casts a 4.5-foot shadow. So this is the shadow, 4.5 feet. The flagpole, here's the flagpole, casts a 15-foot shadow. And if you can see this, these are triangles. And they are similar figures because they're both standing in the same spots outside with the same direction of the sun. So what you're going to do is set up a proportion. So I want to figure out the height of my flagpole, which is x. So I'm going to do 6 over 4.5 because those two go together. Those both are the man's height and his shadow, equal to, well, 6 goes with x and 4.5 goes with 15. So then I have my proportion. 6 over 4.5 equals x over 15. So I get 4.5x equals 90. So x equals 20. So that means the flagpole is 20 feet high. Okay, so try this one. A 6-foot tall person has a shadow that's 5 feet long. A nearby tree has a shadow 30 feet long. What is the height of the tree? So try this problem and then we'll go over it. Okay, so I have a 6-foot tall person, has a shadow that's 5 feet. There's my triangle. And a nearby tree has a shadow that's 30 feet. What is the height of the tree? So how tall is this tree? So I'm going to set up my proportion. 6 over 5 equals, 6 goes with x and 5 goes with 30. So now I cross multiply. 6 times 30 is 180 equals 5x. And then I'm going to divide 180 by 5. 5 goes into 18 3 times, which is 15. And then I have 30 left over. 5 goes into 36 times. So x equals 36 feet tall is the tree. That tree is 36 feet tall. And nobody would be able to really figure that out without using this method, unless you wanted to climb up the tree and measure it. All right. Lastly is maps and scale drawings, and this should just be a quick little review. A scale drawing is an enlarged or reduced drawing of an object that is similar to the actual object. So here's a scale drawing of the map of Michigan. So this is very similar to the actual landmark of Michigan, and then it has a scale here that we use to determine how many miles things are from one another. Okay, so what you're going to have to do is, a scale is the ratio that compares a length in the drawing to the real thing. So the scale for this is 1 inch equals 100 miles. So they will say, okay, so on this map, here's Grand Rapids, and here's Lansing. And they are 1.5 inches away from each other when I measure it. So then they're going to say, okay, figure out how many miles that is. So what you do is you take this scale right here and you make this into a proportion. 1 inch over 100 miles equals, and then my actual one here is 1.5 over X. I don't know how many miles. So then I cross multiply and I do 1 times X is X, and 100 times 1.5 is 150. So X equals 150 miles. Okay, so try this one. A map scale is 1 inch equals 24 miles. About how far is it between two cities that are 3 inches apart on the map? So try this problem and then we'll go over it. Okay, so first you need to set up a proportion. So 1 over 24 equals 3 over X, and make sure you have the inches. See, 1 inch is on top and 3 inches is on top. The inches are both on top, and then the miles will both be on the bottom. So then you get 72 miles. 1X equals 72. All right, that is it for your notes.